I'm on page 36 of the textbook, and this is a high impact lesson. We're dealing with addition and subtraction word problems. Now, anytime you see high impact, that means that it's going to be on the test. So all of these high impact problems are important for us to understand. So let's take a look at this page. We're looking at solving problems with addition and subtraction. Many word problems can be solved using addition and subtraction. To determine how to solve a word problem, read through the problem carefully. Identify known and unknown quantities, as well as which operation or operations you need to use based on the problem. Let me just stop here. Operation is add, subtract, multiply, divide. Then you can use a model and or an equation to determine any unknown quantities. And I think I'm going to clip this problem because it is a high impact problem, and I'm going to copy it into my notebook. So let's go ahead and go into our reference notebook. We had started some of these two-step problems. I'm just going to continue those on the next page. So I'm going to plug this one in, and I am going to copy the problem in because your notebook should be a good way to review. And if you have written this in, you can review it. So Aaliyah has some trees behind her house. Even if you can write in your textbook, I would put this one in my notes. She decides to plant 18 more trees, comma, and now there are 31 trees behind her house. She likes trees, doesn't she? End of sentence. How many trees were behind her house before she planted more trees? Question mark. And I'm not going to use a bar model on this one. You can if you want to, but I'm going to do something a little bit different. We're still going to draw a model, but I'm going to show you a different thing. So the question is, how many trees were behind her house before she planted more? So the key word here is before. We have some information. We know that now there are 31 trees behind her house. We know that she planted 18 of those trees recently. And we're supposed to find out how many trees were there before she planted. So I'm going to sketch her house. And I'm going to draw some trees. I'm going to draw 31 trees because it says now there are 31 trees. And I'm just going to use dots for my trees. There's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So that's the total number of trees that are there now. There's nothing that says your model has to be a bar model. Sketches are awesome to help you visualize what you're doing. Okay, just recently she planted 18 of these things, so I'm going to mark those off. Here's 10. There's 15, 16, 17, 18. So those are the ones that she planted recently. So how many trees were there before she planted those in green? Well, you've got it. All you have to do is count them. You've got 2, and then these. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There were 13 trees already there before she planted. And that's the correct answer. Now, there are lots of ways you can do this. As long as you get 13, you're fine. They did it with a bar model, and that works perfectly well. Here's their total. These were the recent plants. So these are the ones that were already there. That will absolutely work. All right, here is another high impact question. So let's copy it and move it into our notes. I know it's not fun to write these, but it's good to have them in your notes. Before you go take a test, you want to pull out this notebook and review what's in here, and it will help you on your test. All right, Tess has 11 fewer shirts in the dryer than in the drawer. End of sentence. There are 35 shirts in the drawer. End of sentence. How many total shirts does Tess have? And I'm going to leave it right there. It says in the dryer and the drawer, but we can skip that part. You can write it if you want to. Okay, I'm going to do this one for you 2 different ways. I'm going to do the bar model, and I'm going to do just a drawing that we could use. So the first thing I'm going to do is draw the dryer. And then I'm going to draw a drawer. Okay. So here's the dryer. And here's the drawer. She's got 35 shirts in a drawer. That must be a very big drawer. All right, so I'm going to draw 35 shirts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. That's in the drawer. All right. Let's draw 35 in the dryer for now. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's making my head hurt. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. And I will tell you, this is not the way I recommend you do this problem. Okay. Question is, how many total shirts does Tess have? Well, total tells me that I'm going to need to add. Then I will do the ones that she has in the drawer. 35 shirts in the drawer. We got that right here. And we've got all of those marked. Very good. We have 11 fewer shirts in the dryer than in the drawer. So for the dryer, we're going to have to take away 11. If you see a word that ends in fewer, that is a clue that you need to subtract. So it says to subtract 11. So over here for the dryer, I'm going to erase 11. So there's 5. There's 10. And there's one more to make 11. So how many shirts are in here now? If we took away 11, we have 5, 10, 15, 24. So in the dryer, there are 24. In the drawer, there are 35. And how many shirts does Tess own? We could say 35 plus 24. It's a lot of shirts. 59 shirts total. So you can absolutely draw a diagram like that. I would do a bar diagram on this one just because it's easier. But let me show you one. So we want to know the total. That's the unknown. And we know that she has shirts in 2 places. We know that she has them in the drawer. She has 35. And in the dryer, we know that she has 35 minus 11. So that would be 24. And then to get that total, we had to add the 35 and the 24 to get this number, which is 59. And that actually answers the question. We're looking for the total number of shirts that she has. So for me on this one, I would prefer the bar model, but you can absolutely draw a dryer and a drawer. Whatever makes sense to you is fine. There is no right or wrong way, but the answer is 59 shirts in total. So to answer this question, I would use C, and let's look at the hint. They used a number line, and you can absolutely do that too. You could use algorithm only if you can visualize what they're asking. The hint says such terms as fewer, less than, and minus indicate subtraction. Such terms as more than, altogether, total, and sum indicate addition. So let's practice. And I think I'm probably going to need some scrap paper on this one because I don't have room to draw. I don't need to write in the textbook anyway. So let's go to the scrap page. I'll have to add a scrap page. Just put blank in there. All right, so here's the question, number 1. Paulo checks the battery life of his phone at noon. Then he drains 79 minutes from the battery while watching videos. Now Paulo has 13 minutes of battery life left on his phone. What was the battery life of Paulo's phone to start? So for this one, I'm going to use a completely different type of model, but let's mark up the question first. What was the battery life of Paulo's phone to start? So we're looking for a total here, the beginning of this story. How much did he have at the beginning? All right, we know that he drained 79 minutes. Let me not highlight all that. Let's do 79 minutes for videos. And we know that he now has 13 minutes left. For me, I don't know why, but this one seems to be a circle. So you could absolutely draw yourself a circle. Not that circle. Let me try again. I am getting very, very tired, so sorry about that. Okay, so here is his total battery life, the battery indicator. And he's drained 79 minutes, so that's a lot of the battery. Let's do a little section here for the 13 minutes that he has left. So I'm going to make this little section right here, if I can get in here, be the 13 minutes that he has left. So this is what he has not used. He still has this battery available to him. And I'm going to put a 13 there. Now the rest of this has already been eaten up by the video that he watched. So you could color this, or it might be presented to you already colored. And I may regret doing a circle because it's hard to color, but I'll try. Sometimes with these kinds of problems, I'm regretting that already. Let's just do it this way. Let's say that this 79 minutes is what was used. Sometimes they will give you a graph already drawn that you have to read. So I'm trying to give you different viewpoints of the graph. So to start, Paulo had 92 minutes total to start. So I would go with answer D as in dog. Ooh, I don't like that. All right, let's look at number 2. And I'm going to make a copy. Oh, that's an interesting word. Do you know what an apiologist is? Let's see if we can use context clues to figure that out. Ologist is a person who studies. An apiologist notices that there are 46 fewer, there's that word, bees on flowers than in the hive. There are 93 bees in the hive. So which equation could you use to find the number of bees on flowers? An apiologist is a person who studies bees. All right, so the question, the unknown, is the number of bees on flowers. Let me reread this one again. There are 46 fewer bees on flowers than in the hive. So I'm going to use a bar model on this one. And I'm not going to highlight this one just yet, but I will in just a minute. So here we have the total. Oops. Which we don't know. And we have the number of bees in the hive. That's 93. And the number of bees on flowers is 93 minus 46. Excuse me. The question is, which equation could you use to find the number of bees on flowers? So we don't know the total here, and we don't want to know the total here. We're interested in the number of bees that are on flowers. And that is a little bit different than what we've been looking at, but right there it is. 93 minus 46 would be the equation. And there it is. B as in boy. Or B as in bee. That one was just a hair different. All right, this one I think we can do without a model if we read it carefully. There are 48 nuts in a pie. 29 are walnuts and the rest are pecans. How many nuts are pecans? Actually, I am going to do a bar model for this one. Not because I think we need it, but I think it's a good one to show us the concept of the bar model. So let me paste that one right here. We can highlight this one. It follows the pattern we've been watching. So the question, how many nuts are pecans? That's the unknown. The total is 48, and we know that 29 are walnuts. We also have the keyword rest, and that means subtraction somewhere. So let's draw a bar. We know that our total goes on the top or the bottom. You could put it down there if you wanted it. So we have 48 nuts in total. We have two different kinds. We have walnuts, which they told us there are 29. And then we have pecans, and that's the unknown. So this one is a one-step problem. We don't have to do a bunch of different steps. Those are always nice. We do need to subtract. So we have 48, take away 29. So I better borrow. 18 minus 9 is 9, and 3 minus 2 is 1. That means there are 19 pecans in this pie. So I would choose answer A as in apple. Number 4. There are 6 more paintings of landscapes than fruit on display in the gallery. There are 17 paintings of landscapes. How many paintings in the gallery are of landscapes and fruit? So they're trying to mess with my mind just a little bit. But if I know my process, that's a lot harder to do. It's a lot harder to mess with my mind when I know what I'm doing. The question is, how many paintings in the gallery are of landscapes and fruit? And let's get some more information. It tells me there are 17 paintings of landscapes, and there are 6 more paintings of landscapes than fruit. So we are looking for a total. That's the piece that I have not highlighted. That's the unknown. So the total is what I need to know. That's the question mark. I do know that there are 17 landscapes. And I know that there are more landscapes than fruit. The fruit are 17 minus 6. There are 6 more landscapes than fruit. 17 minus 6 is 11. So there are 11 fruit paintings. And there are 17 landscapes. So the total of those two would be, this is a multi-step problem. We would have 17 plus 11, and that is 28 total paintings. So my answer would be 28. And I like answer D on this one. D as in dog. Number 5. A wedding portfolio has 96 photographs including photos from the ceremony and the reception. There are 59 photographs of the reception. How many photographs of the ceremony are in the wedding portfolio? So the question, the unknown for us, how many photographs of the ceremony are in the wedding portfolio? So the unknown is the ceremony pictures. So we should have a total, and we do. That's the 96. And we have another piece of information. 59 are of the reception. So this is a one-step problem. You could do it with an algorithm if you already know what to do, but I'm going to draw the model in case you don't. Let's put our total up here. Total is 96 photos. We know that 59 are reception. And the rest would be ceremony. And this is the unknown for the moment. So we would say 96 minus 59. Better borrow. That would be 7 and 3. So 37 of the photos are ceremony photos. And I like B as in boy for this one. Number 6 already has a model drawn, so I'm not going to draw another one. I am, however, going to highlight total items for delivery. 64 are letters, 17 are postcards, and the unknown is the number of boxes. According to the model, how many boxes are in the postal worker's delivery? Well, I know that there are 93 total items, minus 64 letters, and 17 postcards, and whatever's left will be the boxes. So we want to do that part first. This is your total, and this is your unknown. So let's do 64 plus 17. That's 11. So 8 there. And then I'm left with 93 minus 81 will give us the number of boxes. So 93 take away 81, it's going to be 2 and 1. So there are 12 boxes to be delivered. I like A as in apple. That is a multi-step problem. Number 7, they did not give me a model, so let's draw one. So let me clip the problems and go to, I need a new piece right here. A dry cleaner has 32 shirts, some dresses, and 24 pairs of pants. A total of 76 items is at the dry cleaner. How many items are dresses? So we know that we have a model. Do we know a total? Yes, we do. A total of 76 items is at the dry cleaner. So total is 76. Then let's figure out what else we know. We know that there are 32 shirts, some dresses, 24 pairs of pants. So we don't know the number of dresses yet. So let's divide this into 3 sections for those 3 types of clothing. And we have 32 shirts. We have 24 pairs of pants. And the unknown is the number of dresses. So because this one's pretty complicated, let me highlight for you on these numbers, and that may help trigger the process. We're going to take the total minus the shirts and the pants, and that will equal the dresses. So let's do this one first, where we have 32 and 24. That's 56. And 76 minus 56 is 20. So there are 20 dresses at the dry cleaner. So I like A as an apple on that one. 20 dresses. All right. Joe listens to 39 minutes of a podcast. Later, he listens to 23 minutes of the podcast. The podcast is 91 minutes long. How many minutes remain in the podcast? So, the word remain is a clue. That's a subtraction word. And I am going to use a model on this one, but first let's do some highlighting. He listened to 39 minutes. He listened to 23 minutes. The total of the podcast is 91 minutes. So the model would look like this, where we do know the total is 91 minutes. We have 3 sections. We have the 39 that he listened to, the 23 that he listened to, and then the unknown is how much remains. Total, what we know, what we don't know. So this one I would say 91 minus the 39 and the 23 leaves me with what remains. So 39 and 23, put it right here. We're adding those. That's 62 minutes. And then 91 minus 62 will give us the remaining time. 91 minus 62, better borrow. Looks like 29 minutes remain. So I like answer C on this one. C as in cat. Number 9. Pam orders 89 holiday cards. Which equation shows how many cards she can send to her side of the family and how many she can send to her husband's side of the family? Oh boy, this is an interesting question, so I think I am going to take it to my scrap paper. And we're going to have to make an assumption here that each side of the family gets the same number of cards. Well, they can't get the same number of cards because the 89 is an odd number. But let's see what we can do here. 89 holiday cards. And actually, I think I'm just going to go back to the options because really I can't do anything. We need to see the equations that we have to choose from. All right. We know the total is 89. So whatever we come up with, it has to equal 89. Let's go at it that way. We're looking for something that equals 89. 8 times 9 is 72. So that's not our answer. 47 and 42. Let's try this one. That's 89, so that's a possibility. C is 49 plus 45. That's 94, so that's not it. That would be a 94. And then 80 plus 90, we can just add the rods together to get 17 rods. So the one that fits is B as in Bravo. I was thinking we don't want to make assumptions, and we don't. We have to pick the equation that balances with that 89. So either the husband's side or Pam's side gets 42, and the other side gets 47. Number 10. Whitney works on a crossword puzzle with 65 clues. She fills in 42 more clues than she erases. She erases 5 clues. How many clues does Whitney still need to fill in to complete the puzzle? Okay, don't let this one mess with you. You know how to do it. It's not easy, but let me get rid of this one about Pam and that bit of highlighter. And then I'll post this problem in. Okay, so let's break it down. The question, how many clues? Sorry, that's not the total, that's the unknown. How many clues does Whitney still need to fill in to complete the puzzle? So the unknown in this question is how much she still needs to do. All right, do we know a total? We do. The crossword puzzle has 65 clues. We know that she filled in 42. We know that she erased 5. Sorry, she fills in 42 more than she erases. I was getting a little bit tangled up there. For some reason, this one's messing with me, but let's see what we can do here. All right, we know the total is 65 clues. We know that she erased 5. We know that she filled in 42 more than she erased. So that's 5 plus 42. That's 47 that she filled in. And so the remaining ones are the unknown. This is why it's messing with me. And I'm actually going to consult the answer key before I answer this question. So if you'll give me a second, let me look at this problem because I'm very sleepy and I don't want to make a mistake here. So 10. I don't like this question. It just messes with me. Yes, okay. I had it, but I was doubting myself. This is where it's different. And they absolutely can do this on a test. The erased clues are still remaining. So we are not going to even factor those in. We are just going to look at the number filled and the number remaining. So by taking out that erased part, this becomes a one-step equation again. You can just do the algorithm or you can set it up however you want it. But you're going to do 65 minus 47. That's what's bothering me about this one. 15 minus 7 is 8, and 5 minus 4 is 1. So 18 clues remain. And that should be, I keep going back to our reference book because I'm sleepy. 18 clues remain. A as in apple.